Hi everyone, I hope all of you are doing great. So in today's video, we'll discuss about one of the most asked question in the Playwright interview that how have you implemented OOPS concept in your Playwright framework? Now, as you can see, this is one of the very last question in our series, but I'm covering it early because the importance this question has, and there are many counter question or the cross questions the interviewer might ask you from this same topic. So you have to be really clear about this thing. Now, if you're not familiar with OOPS concept, I will just give a brief overview of it in just 2 minutes so that you get a better clarity of it. Now, what is OOPS? OOPS is basically object-oriented programming system. So it is not a programming language, it is a programming paradigm or a style of programming that is centered around class and objects, right? Now, what are classes? So, classes are blueprints from which the objects are created. So, class doesn't occupy any memory in the real world, but object occupies memory when it is getting created. You can always remember class and object like the basic example of a house plan or a structure of a house, a plan of a house. Let's say it is a class, and from this, the house is built. Now, once the house is built, it occupies some space, right? So this is the object. And from the blueprint from which the object is created, this is called class. So that's the basic idea of class and objects. Now there are majorly four pillars in object-oriented programming: inheritance, polymorphism, abstraction, and encapsulation. Now what is inheritance? Inheritance is basically from the parent class, the child class will get all the properties and methods and attributes, right? So it will inherit the properties from the parent class to the child class. This is basically inheritance. Next comes polymorphism. Now, as the name suggests, poly means many and morphism means forms. So polymorphism means in many forms. So a function can perform different tasks. Similar functions can perform different tasks. That is polymorphism. I will discuss it further when I will give you the example. Now, what is abstraction? Abstraction is basically hiding the implementation and showing the necessary details to the user. So the user will not know how the program is implemented or how the method is implemented. He will only can use it or show the or the user can only see the implementation part of it, right? So that is all about abstraction. And when we do full abstraction or pure abstraction or 100% abstraction, it is called interface, right? I will discuss this further as I have already told you. Now, what is encapsulation? Encapsulation is basically binding the data and code together to achieve data security. So that is encapsulation. Now, this is a very basic idea that you can have about object-oriented programming. Now, let's go back to our main topic, that is how you have implemented that in the framework. Now, we have implemented OOPS in Playwright using the page object model with encapsulation, abstraction, inheritance, and polymorphism. For what purpose? To build a scalable and maintainable framework, right? Now, so we have implemented page object model as OOPS foundation where each page will act as a class. We'll define each page as a class. Each action acts as a method. Wherever you are clicking on any element or performing any action, that will act as a method, and each locator will act as a property. Using this, what we will achieve? So these are the goals that we are achieving when we implement OOPS concept in our framework. It will reduce duplication. So you will have common codes in a common folder from which you can reuse the code, right? So you can reduce the duplication. Then you will introduce modularity. You will maintain a separate page folder, you will maintain a separate locators folder, a separate test folder. So you're introducing modularity in the framework. You will be able to do faster maintenance. Now let's say tomorrow a locator gets failed. You no need to go through the entire code. You can just go to the particular locator file and change that locator and the test will run again. So at the end, it will provide a cleaner test structure. So these are the goals that we are achieving when we implement OOPS concept in our Playwright framework. Now let's discuss it further one by one. So what is encapsulation? That we have already told you that sorry. So encapsulation is bundling data and methods together for data security and controlled access. So how we have implemented it? We keep the locators and methods private inside the page classes and expose only reusable actions. This hides implementation details and reduces test maintenance, and also it introduces data security. For example, I'll just explain it to you here. So we have a class login page inside which we have the locators. We have defined the locators using private scoped. Now you can also use read-only username and read-only password. Now when as we have used private, these locators will not be accessible outside this class. So outside the login page, these locators cannot be accessed or the values cannot be changed. Similarly, if you have mentioned here read-only username and read-only password, then also the values cannot be changed. Now, how we are accessing these values? So let's say in the login page we have a function, we have a method login that will perform the login action. So we are filling up the username and we are filling up the password. So when in the test class, we'll only call the login function. We will not access the locator here, right? We'll only call the login function. In this way, we are securing that our locators are untouched in the code, right? And it will hide the locators also. So that's how we are achieving encapsulation. Now let's move forward to the next concept, that is abstraction. So if I talk about abstraction, abstraction is hiding implementation and showing only the necessary actions to the user. So in the test, we only call high level methods. So the example that I have already given you, what I have told, that in the page class, I have defined this login method. Now in the test class, I will call this login method. See here. In the test class, I am calling the login method. I will create a object of the login page and I will call the login method here, right? And that's how I am accessing the page classes methods. So in the test, we only call high level methods from page class. So the user doesn't know how the method is implemented. It provides cleaner test and focuses on business logic. So in the test class, we will be only calling the page methods. There will be no implementation in the test class. And that's how we are achieving abstraction in our framework. Now let's come to the next concept, that is inheritance. What is inheritance? Inheritance is extending the properties from parent class to the child class. How we are achieving that? Now there can be two examples. One I have given you here and another one I will explain you. One common example of using inheritance in the framework is, let's say you have a base page. Let's say you have a base page and from the base page you are extending three other pages. So all the base page methods will keep our common methods in our base page, and from the base page all the other pages will get these common methods. So this is one example of inheritance. Now I will explain you the example I have given here. So we have a login page here, right? And then we have admin page that extends the login page, right? This admin page will extend this login page, and the user page also extended from the login page. So this login function that we have here is accessible by the admin page, and this login function is also accessible by the user page because a admin can log in and a user can log in. Just think of it from the business perspective, right? That The admin also can log in, but it will have its own function like delete user that the user will not have. That's why we have a separate page. Now, similarly, the user can also log in and it will have its own actions like update profile. So that's how we are achieving inheritance in our framework. So just see this, we use a base or common page for common methods and extend other pages from that page. That will reduce duplication and implement it centralized updates, right? So you no need to update. So if tomorrow there is any change in the login method, you no need to update in all the classes. You just need to update in the base class, right? I hope you get it. Now let's move forward to the next concept, that is polymorphism, that I have already told you that same methods to perform different tasks. So similar method will perform different kind of task. Now in polymorphism there are two popular concepts. One is method overriding and one is method overloading. Also, the method overriding is known as runtime polymorphism and the method overloading is known as compile time polymorphism. Now, what is method overriding? See, we'll have the same function in the parent class as well as in the child class. So this is the parent class and this is our child class. So in the parent class and in the child class, we'll have same function. But why we have it? Just see this example. In the login page, we have a login function. Now the admin login is extending the login page, so it can access this login function, but it is overriding the login function. Why? Because maybe the admin login needs some other implementation. So that's why we're overriding the base login function. So that is method overriding for you. That same method in parent class and child class. Child class, we override the parent class method to perform some different action. Now let's jump onto the next concept, that is method overloading. Now in method overriding, what you have seen, similar methods present in two different classes. This is the first class, which is the parent class, and this is the second class, that is the child class. But for method overloading, similar methods will be present inside the same class. That's the concept, but the parameters will be different. So method overloading is same methods in a single class, same method name but different parameters. In case of method overriding, the parameters will be same also. But in case of method overloading, the parameters will be different. And here I have mentioned the example from Playwright default function or built-in Playwright built-in functions. Like we can page.goto and we can provide the URL, and we can use the goto function with a timeout also. So we are passing two different parameters to the same function and it will behave differently. Like it will throw a error, timeout error, that after this 60 second, 1 minute time is exceeded. So it will throw a error. Similarly for click also we can mention is as a forced true, which will perform the click action no matter what happens, right? So this is all about method overloading and method overriding under polymorphism. Now we'll talk about interface. Now, to be honest, interface I haven't implemented in my framework, but if the interviewer asks you and if you want to give the answer that where you can use it, so I have given you an example. This is popular in case of API testing framework, but in case of Playwright, I haven't used it. But I have mentioned a scenario where you can use it. So we'll discuss about it. Now, what is interface? Interface is pure abstraction, means all the necessary details will be hidden. But if you go by the definition, abstract class, sorry, in abstraction, it can contain abstract methods as well as non-abstract methods. But in interface, it will only contain abstract methods, right? So let's not discuss about the definition, but let's see the implementation here. So we have implemented a test data interface to define strict contracts for test data and fixtures, ensuring consistency and type safety across the framework. So what we are doing here? Let's say you have a test data users.json where we have the username, password, and role. Now you are providing a type for it. You are defining a type for it that the user data should be inside the user data. The username should be of string type, password should be string, and the role should be admin and user, so that when you are loading that user data, it checks that the type is user data or not. User has to be a type of user data, otherwise the TypeScript will throw a error, right? So in case, so to just restrict others from, let's say if someone tomorrow comes and he mentioned the role as some other role, let's say administrative he mentioned, so it should not accept that, it should throw the error. So that's why that is one case where we can use interface to give a outline of our test data. Now we have already discussed about all the OOPS concept and how we have implemented in the framework. Now one question that the interviewer might ask you, that is TypeScript a OOPS language? Or sorry, is TypeScript supports OOP? Now TypeScript is not purely a object-oriented language. It is a multi-paradigm language that supports object-oriented programming, because TypeScript eventually compiles to JavaScript. So when you run our Playwright code, it in the intermediate step will compile all the TypeScript code to JavaScript, and then it will perform all the actions, right? And JavaScript itself is a prototype based language and not a pure class based object oriented programming language like Java. So TypeScript is not, so the gist is TypeScript is not a purely object oriented language. It implements object oriented concepts. That's it, right? So TypeScript basically adds object-oriented programming syntax and type safety on top of JavaScript. So the interviewer might ask you this question. So I have mentioned it here so that you can, while revising, you can um, get the idea of it. So that's all about this video. If you have any doubt, let me know in the comments, and we'll see you in the next one.